Okay, guys, we are going to begin reviewing relations and functions to prepare us for Unit 1 of Pre-Calculus. So, let's talk about, that wasn't working, relations, okay? Relations compared to functions. Relations are a set of order pairs. Not necessarily, a relation can be a function, but remember, a relation does not necessarily have to be a function. We learned all of this last year at the very beginning of Algebra 2 Trig. So, relations are a set of ordered pairs, and they can be shown in a table, they can be shown in mapping, they can be shown in a graph, or they can be shown in an equation. So, a lot of times in math, we see them in the last two in graph and equations. And this unit is going to transition, once we finish this review to get your math wheels rolling again, this unit is going to transition into more complex functions, but using what we learned last year and our ideas of y-intercept and all that fun stuff to help us find important features of functions. But relations, we know that they have a domain as the x values, and that range is the y values. We know this. Now, functions. Each element of the domain is paired with exactly one element of the range. Hopefully you may even still have these notes if you kept your binder. So exactly one element, each x is paired with one y. There is no repeating of x's. So we have an example, 0, 1, negative 5, 2, 6, negative 2, 5, 6. Our domain are our x values, 0, negative 5, 6, 5. Okay, do any of those repeat? No, so that one is a function. Let's look at the next example. We have negative 7, 6, 6, and negative 3. 6 and 6 repeat. So this relation is only a relation. That is all it is. It has no special, it doesn't meet all the other special requirements to be a function. Functions, so we just looked at them in ordered pairs, and now we're going to look at them in graphs. So remember, we would have a graph. This one's just a linear function. We are very familiar with linear functions. And we had to see if it passed the vertical line test. Or maybe we have this circle. We need to see if it'll pass the vertical line test. So there we go. We have a vertical line. And we're going to see if it will pass. Yes, that vertical line just went all the way across our graph. And did it ever touch the graph more than once? Let's look at that again. I don't know about you, but what I saw was that peach line only touched the green line at one spot at a time. Let's look at the circle. Here's our vertical line. We're going to take it across. What's happening? What's happening right here where we just paused this line? It's touching in two spots, right? So we remember that we learned that this was not a function. The line is a function, the circle is not a function because the circle failed the vertical line test. Okay, example 1, we're going to determine if this relation is a function. Maybe, if it will. Okay, domain and range. We need to find the domain and range, and we need to determine if it's a function. So I gave us a set of ordered pairs. What's the domain? Negative 1, 0, 4, and 6, right? I want you to look at the function, the relation again. I want you to determine what the range is. The y values, right? Negative 9, negative 5, 3, and negative 2. Is this a function, yes or no? We're looking at our domain. Do we see anything repeat? Do we see any numbers listed twice? No, we do not. So yes, this is a function. And remember, when we list our domain and range, that's called set notation, and we're going to list our elements of our domain and range from least to greatest. So keep that in mind. Function. This time we have a table. So we had an ordered pair, this time we have a table. Remember, tables are just a different way of representing ordered pairs. So what's the domain? Negative 4, 0, 2, 7. What about the range? 3, negative 1, 3, negative 8. We really should have listed that in least to greatest. Oops. Okay, is this a function? Yes, it's a function. Does in my domain, do any of those numbers repeat? No, so we know it's a function. Example 3. Find the domain and range of the relation, determine if it's a function. we want to find, it's a mapping, right? Okay, what does this map represent? Each line is paired with, pairs an X with a Y, and that creates an ordered pair. But our domain is what is in our first oval, our range of what is in our second oval, and remember, because 5 has 2 lines drawn with it, that means it's paired with the 7 and with the 9, so that is going to make it no. Okay, here's a key thing. See how our domain only has 3 numbers in it, but our range has 4? That's a key. That is a signal of, hey guys, something's wrong here, without you necessarily even having to know how to interpret the map. Because you know the map, the first oval is an X, and the second oval represents the Y's, and there's only 3 X's, and there are 4 Y's, you know one of them has to be doubled. Okay, now this is the part where you all had more difficulty last year. So we're going to review this more in depth. We're going to determine the domain and range of the function. It's going to be a graph, okay? All the next 4 are going to be graphs. So we have these points. They're ordered pairs, -3, 1, -3, -2, 0, 0 at the origin, 2, 2, 3, -1. We need to determine what the domain is. We have 5 points. How many domain elements should we have? 5, but why do we only have 4? Because the -3 is repeated, right? Okay, so we listed -3, 0, 2, and 3. What about the range? We have 5 because we have 5 points, -2, -1, 0, 1, and 2. Once again, our domain only has 4 elements listed. Our range has 5 elements, so we know that one of those domains have to double up. So it's having to cheat, right? So it is not a function. It is not loyal. Okay. And we see that. We see the 2 points that cause it not to be a function. Okay, now getting into items that are more complicated. We see this line, right? We have to determine the domain and the range. And so here's our domain. Okay, we're going to watch it again. Domain is X, so we're lines drawing it across in an X. Is there anywhere that this function was not? No. It wasn't, okay? Because those lines are going to keep going forever and ever. So even where the peach line has stopped right now, and there's not technically a graph still there, we know that if our coordinate plane was bigger, that we would still see that line continue to increase, the green line. Okay, so that means our domain is all real numbers. X exists such that X exists in all real numbers, okay? X is going to be all real numbers. Any number in the real number system will be in the X. Okay, range. That's our Y's. We're going to go up, 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 up. Is there anywhere that our range is not? This one kind of has the same thing as last time, where down here in the bottom, right here in this section, not anymore, but the very first section where there was that gap. But we know if our graph was bigger and it was zoomed out farther, that we would see that line continue. So our range is Y such that Y exists in all real numbers. And then is this a function? Yes. Okay, same thing. Different function, still a graph. So we need to determine the domain, the range, and the function. So that is our domain. That's where our function's at. Okay? In that shaded area. This is not an inequality. I'm just shading that area so that you can see that there's no function behind the shaded part, to the left of the shaded part, to the negative. So we have our line. That's where it starts for domain. Let's pull it across. Is there anywhere, once we started, was there anywhere it did not go? No. So we started at what point? We started at -4. And then anything greater than -4 is going to make that function true. So our domain is X such that X is greater than -4. All right, what about our range? Okay, is there anywhere that our range is not? No, because we have those 2 arrows, so it's going to go up to positive infinity and down to negative infinity forever, ever, amen. So Y such that Y exists in all real numbers. Is this a function? No. That peach line, whenever it went across, it failed the vertical line test. All right, our last one. I want you to try this one yourself. We have a circle. Well, that's not a circle. We have an ellipse. Okay, I want you to find the domain, the range, and the function, determine if it's a function or not. I'm going to give you 20 seconds. Are you ready? Are you sure? You are. Let's go. All right, 20 seconds is up. Domain, what did you decide about the domain? Where does the function exist? The function only exists right here in this gray shaded area, right? Okay. On x-wise, we begin at -2. Where do we end? At 5, right? So x such that if we begin at -2, why did I type a 4 there? Guys, I don't know why I typed a 4 there because that's supposed to be a 5. Oops. Okay, that's supposed to be a 5. Now, so our graph is in between -2 and 4, right? So that's what that says. X is in between -2 and 4. X is greater than -2, less than -4. It's also equal to -2 and 4. What about our range? It starts at -2 and it goes up, 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 up to 4. So y such that, okay, I must have just got backwards, guys, because I typed a 5 right there. I am so sorry, that's supposed to say a 4. Oops. Okay, so is this a function? No, it failed the vertical line test, right? Okay, so this was just a quick review of what we learned in the very beginning of Algebra 2 Trig. I hope this helped. We still have more review to do and more extension on these topics.